Students, uh, today our topic is chemical properties of alcohols. In this, oxidation of alcohol, first we'll see this. But before starting this, actual reaction, first we'll see some table here which will require during reaction. Like primary alcohol on oxidation gives aldehyde, and aldehyde on further oxidation gives acid, carboxylic acid. Now primary alcohol is CH2OH, aldehyde is this CHO, carboxylic acid is COOH. Now in this primary alcohol, the number of carbon remains same throughout the reaction. Like if you have 3 carbon, 3 carbon, 3 carbon, that acid which is obtained contains same number of carbon which is there with alcohol. Same way, we'll go for secondary alcohol. Secondary alcohol on oxidation gives ketone, which on vigorous oxidation gives acid, which is carboxylic acid. But here, secondary alcohol, we can write it like this. Functional group of ketone is this here, and for acid is COOH. But in this, important to note is number of carbon. If we have 3 carbon here, it is 3 carbon, but acid contains 1 carbon less than alcohol. These two tables will help you to write oxidation of alcohols, the question which I am going to do. But before going for the question, you just write and keep this will require. And what I'll do, otherwise I'll write it here in short and then we'll use that. Okay, that is, I'll just write and keep here, that is primary alcohol on oxidation gives aldehyde, aldehyde gives carboxylic acid, and secondary alcohol gives ketone, and ketone on vigorous oxidation gives carboxylic acid. And number of carbon, as I said, in primary, number of carbon remains the same throughout the reaction. And for the secondary, what happens? Acid contains 1 carbon less than alcohol, secondary alcohol. Okay. Now, if question is action of acidified potassium permanganate or potassium dichromate on primary alcohol, secondary alcohol and tertiary alcohol, what happens? So for this, we'll start with primary alcohol. So primary alcohol, for example, we'll write here propane 1-ol. So when propane 1-ol is reacted with acidified, I can write here any I can write KMnO4, or to that place I can write potassium dichromate, and here acid can be like nitric acid, can be dilute sulfuric acid, Okay, so what happens now here? These two, potassium permanganate or your potassium dichromate, when they react with acid, they produce three oxygen, three atoms of oxygen. So out of three, one is utilized here. And now we'll see what happens. As you can see in this table, this primary alcohol, so primary alcohol on oxidation gives aldehyde, means this part here. This gets converted into aldehyde. And plus what comes out is water. How this aldehyde is formed? See, hydrogen, alpha hydrogen comes out, and hydrogen from functional group. I'll just remove this. Yes, hydrogen is coming out from alpha carbon and functional group. This becomes water. See, water molecule is given out, and what forms is aldehyde. But this reaction will not stop here. Why? See, primary alcohol requires one oxygen to give aldehyde. Now aldehyde requires one more. So here one more oxygen, further oxidation, and we get CH3CH2COOH. Means propane 1-ol gives propanoic acid. Acid containing same number of carbon. So this is for primary alcohol. Now we'll go for secondary alcohol. Now in case of secondary alcohol, I'll write, for example, secondary alcohol is propane 2-ol. Okay, when this is reacted with, see, you can write potassium permanganate or you can write potassium dichromate. It can be nitric acid or maybe sulfuric acid. What this acidified potassium dichromate produces here? Oxygen. So this oxygen, nascent oxygen, is obtained from. Okay, now we'll see. Same way here, alpha hydrogen, and this hydrogen from functional group, water molecule is given out. Say this, water molecule is given out. Water molecule comes out, and what forms here is this ketone and plus water. Acetone. Acetone contains same number of carbon. See this, till here, if we have 3 carbon here, 3 carbon is there, but this 2 carbon. Means further oxidation, we can get acid. Acid can be obtained, but vigorous oxidation you have to do. Vigorous oxidation is required. 4 oxygen atoms are required, which is not possible here. Why? Because potassium dichromate, when reacts with sulfuric acid, it produces only 3 atoms of oxygen. And for this further, see, I have given ketone can give acid. See this, 3 carbon becomes 2 carbon. 3 can become 2. This can be done, but not by acidified potassium dichromate and potassium permanganate, because they produce 3 oxygen. And here we require, in all, if you'll count here, we require 5. See this, 1 and 4. Total we require 5 atoms of oxygen. And that's why the reaction stops here. No further reaction. So what primary alcohol gave here? that primary alcohol gives acid, but secondary alcohol gives ketone only. Till ketone, no further reaction. Okay, now we'll see what happens with tertiary now. Tertiary alcohol. For tertiary alcohol, say it is CS3C, tertiary butyl alcohol. When it is reacted with, say, acidified potassium dichromate, this produces oxygen. But we can write here no reaction. Tertiary alcohols does not undergo oxidation. Why? What is the reason for that? The reason here is due to absence of alpha hydrogen. See this, functional group is attached here. This alpha carbon here, alpha carbon, this alpha carbon does not contain hydrogen, means no alpha hydrogen. Just see, when we were doing this primary alcohol, this, and secondary alcohol, that time what we did, I said alpha hydrogen comes out, hydrogen from functional group comes out, and this oxygen which is there, water molecule forms here. In this case also, see this, oxygen is there. So from here hydrogen, alpha hydrogen, functional groups hydrogen, this water molecule is formed. Alpha hydrogen is must, and in this alpha hydrogen is not there, and that's why oxidation cannot be done. But with acidified potassium dichromate and permanganate we cannot do, but it can be say oxidized using strong oxidizing agents like CrO3. So that is another topic we'll take, oxidation of alcohols. But here actually what we are talking about is, if question comes, how will you distinguish between primary, secondary and tertiary alcohols by using acidified potassium dichromate or potassium permanganate? So here, for example, just say this, if we have 3 samples here, say sample 1, 2, 3, we don't know in which sample what is present, which alcohol is there, and this 1, 2, 3, these 3 samples are of alcohol. Now when this potassium dichromate and this sulfuric acid is added in all 3, suppose if you got here ketone, in this no reaction, and here you got carboxylic acid. Now it becomes easy to answer that the alcohol which gives ketone is secondary alcohol. The alcohol which is showing no reaction is tertiary alcohol, and the one which gives acid is primary alcohol. So hence we can distinguish, if 3 samples are given, put acidified potassium permanganate or potassium dichromate, you'll get, if the 3, one will produce acid, other produces ketone, one sample will not react. On that basis we can distinguish primary, secondary and tertiary alcohols. Okay. Now there's one problem, that if question is, means this was one question, now another we are doing, another topic now we want to go for, that is, suppose if question is convert ethanol into ethanol. Okay, this question is there. How to write answer for this? Now, first we'll do arrow. We want to convert ethanols. We'll write ethanol here, CH3CH2OH. Okay. Now ethanol. Okay, ethanol, we'll try to write structure. Al for aldehyde. And eth means 2 carbon. 1 carbon is already there, 1 more carbon. Okay. Now, can we use that acidified potassium dichromate here? No, because it produces 3 oxygen. And here, from primary alcohol to aldehyde, we require only 1 oxygen. If you will put acidified potassium permanganate, you will get acid. To stop this reaction at aldehyde, we require mild oxidizing agents like PCC, pyridinium chlorochromate. So here we'll use PCC, which produces here 1 oxygen. Now further, you know what happens. Hydrogen comes out from alpha carbon, and from functional group this water molecule is given out, and water. But for this question, one more answer is there, or what we can do is, ethanol is when heated with copper at 573 Kelvin. This reaction is known as dehydrogenation, because in this reaction, say this hydrogen comes out and we get ethanol plus hydrogen. So for this question we have 2 answers, with PCC and with copper. Now we'll take another question. Now if the question is obtain acetone from isopropyl alcohol. This time our question is obtain acetone from isopropyl alcohol. Okay, whenever question comes, right arrow, what you obtain is acetone. So the structure of acetone is this, CH3, C double bond O, CH3. And isopropyl alcohol, so isopropyl alcohol is CH3, CH3 and OH. Now here, see, in primary alcohol, that acidified potassium dichromate we didn't use, but here it can be done. Here we can do it. Say here we can write potassium permanganate and sulfuric acid. Produces oxygen here, and rest you know that hydrogen comes out from alpha carbon, and from functional group water molecule is given out. This further reaction will not occur here, because for further oxidation we require 4 atoms of oxygen, which is not produced by this. Okay, now say or same reaction we can do with PCC. pyridinium chlorochromate. Same thing you'll get. For this question, 3 answers are possible. Even one more. Or this isopropyl alcohol is when heated with copper at 573 Kelvin, again dehydrogenation. So dehydrogenation gives acetone. So for this question, to obtain acetone, acetone can be obtained from isopropyl alcohol with acidified camenophore, with PCC, with copper by heating at 573. So for this, 3 answers are there. Now, another question. But before going to that question or that topic, that is oxidation of tertiary alcohols, I want to give one table here which will help you to write oxidation reactions. See this? For primary alcohol and secondary alcohol and tertiary alcohol, when they are reacted with, say, acidified, I'll write it this way, like say camenophore, or it can be potassium dichromate, and I'll put H plus. Okay, acidified. And other is PCC. One more I'll write with copper at 573 Kelvin. And finally I'll write CrO3. Okay. See what happens. Here alcohols. So primary alcohol gives aldehyde, secondary alcohol gives ketone, and tertiary alcohol no reaction. Now with PCC, aldehyde, by mistake acid, this is acid, carboxylic acid. Actually just now we did acid. Primary alcohol gives acid, ketone this. Aldehyde, here ketone and no reaction. Okay. For this, again aldehyde is there, here ketone, and this gives alkene. Now with CrO3 you can write carboxylic acid, here ketone, and this gives ketone. If you'll go through this table, you will not have any problem in writing oxidation of alcohols or solving any question which is based on oxidation of alcohols. See, because all 4 which are there in syllabus, I wrote all. You can just see this. Secondary alcohol gives ketone, 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 ketone. It's easy to remember. In all, ketone, ketone is there. And for this, with acidified potassium permanganate, it gives acid. And then with CrO3, why CrO3 gives acid? Because it's strong oxidizing agent. And these are like this mild oxidizing agent, and copper is you can say reducing. So now this, actually now we want to go for tertiary alcohol. So tertiary alcohol, this we did, no reaction and no reaction. Actually we have to say this. What happens when tertiary alcohols are reacted with copper? Or what happens if it reacts with strong oxidizing agents like CrO3? So that 2 reactions now we have to see. Now this time question is, if it comes, action of, if the question is action of copper on tertiary butyl alcohol at 573 Kelvin. What happens? So tertiary butyl alcohol is this, when it is heated with copper at 573 Kelvin. As you know, what we did in primary and secondary, hydrogen comes out from alpha carbon and from functional group. But now in this, there is problem. Alpha hydrogen is not there. So, if it is not there, so hydrogen comes out from beta carbon. So, beta carbon is this, beta, this beta, here is beta, beta carbon. So, hydrogen can come out from any of these three beta carbons. So, suppose if I'll remove from here. So, water molecule is given out. You will get CH3, C, double bond CH2 and CH3 and plus water. Alkene is formed. Dehydration reaction. When primary alcohol and secondary alcohol, they are reacted with, like heated with copper at 573 Kelvin, they produce aldehyde and ketone respectively. And this reaction is known as dehydrogenation. In this two case, it is called dehydrogenation. But here, in case of tertiary, this is dehydration reaction. This is dehydration. Okay. Now the last topic, that is oxidation of tertiary alcohols. They can be oxidized, but using strong oxidizing agent. So that is, we'll write here, oxidation of tertiary alcohols. So tertiary alcohol, for example, is this tertiary butyl alcohol. When this reacted with CrO3, reacted in the sense heated with CrO3. So what happens? Again, dehydration reaction. The problem is what, alpha hydrogen is absent. And because of that, hydrogen comes out from beta carbon. So we get alkene. Just now I did, this alkene we get, which is isobutylene. Now further, what happens? CrO3 is having double action. First, dehydration and then oxidation. So now further oxidation, 4 oxygen. CrO3 produces 4 here. So now we'll see that 4 oxygen, 1, 2, 3, 4. This carbon reacts with 2 oxygen to form CO2. Hydrogen reacts with 1 oxygen to form water. Now this remaining oxygen gets joined there. It forms acetone. And further oxidation now we cannot do here. It stops here. So tertiary butyl alcohol gives ketone. Now, as I wrote, when we started our class, that time I wrote primary alcohol on oxidation gives aldehyde and further, right? And for secondary alcohol also I wrote oxidation gives ketone and further oxidation. Same way, now I will write for tertiary alcohol. For tertiary alcohol, we can write it like tertiary alcohol when reacted with CrO3, first it gives alkene and further on vigorous oxidation, it gives alkene. So if you have 4 carbon here, you'll have 4 carbon, here 3 carbon. Further oxidation can be done actually. We can do 4 oxygen, so it can give carboxylic acid which contains one more carbon less than alkene. By mistake, here, just now I wrote, ketone. Okay. Now, actually here, in all cases, if you compare, in case of primary alcohol, secondary alcohol, tertiary alcohol, when they are oxidized, they finally, if you check in all cases, final product I have given acid. They form carboxylic acid, but in case of primary alcohol, it gives acid containing same number of carbon. In case of secondary, it gives acid containing 1 carbon less. And in case of tertiary, see this, 4 carbons are there, right? But the acid which can be obtained contains 2 carbon less than alcohol. Now you might be thinking, sir, why you stopped here at ketone? Why not this acid? Because after adding CrO3, reaction can be done till ketone. For further oxidation, you require more CrO3. And that's why we show till ketone. But finally, what I have given, if you'll go through, in all the cases, see, all alcohols on oxidation, finally they produce carboxylic acid. Finally, acid is obtained. And what is important here to note, primary gives same number of carbon, 1 carbon less, 2 carbon less than the alcohol.